Today I am going to solve examples and normal distribution. To find the first one, to find the area under standard normal. These are the given curves, z equal to 0 and 1.2. So first example, we will solve first one for z equal to 0 and 1.2. Theoretically, the area is, in the last class I have given you the formula for area. Theoretically it is written by 1 by square root of 2 pi integral over 0 to 1.2 e raised to minus z square by 2 dz. So this is nothing but phi of 1.2. So actually using the table, so for the first example just I am giving you the referring the table, we move vertically down along the column. This is how to use the table, the method of using the table to find the value. Column of z to reach 1.2 and then move horizontally if the value, if the next value exists. That is means what? As I have given the table, so here this is our z column. These are 1 to up to 9 numbers. This is a vertical, this is a horizontal line. So our line we required here 1.2, directly 1.2, only 1.2 we have. So for the 0 column, so this is vertically move down and then horizontally, since it is only 1.2, so 1.0, so 1.20 is 0.3849. If you are given with 1.22, then we have to move horizontally along this line, and for the second column, that is 1.22, your value will be 0.3888 like this. So for now, for this problem we have only 1.2, so value will be 0.3849. So likewise, so phi of 1.2 will be, hence phi of 1.2 is 0.3849. Equivalently, we have probability of z less than or equal to between 0 and 1.2 is nothing but phi of 1.2 is 0.3849. So next illustration, the graph of this curve, it looks like for 0 to 1 to 3. The curve is like this, then phi z, this is phi z, and here z equal to 0, so z equal to 1.2. This is the area of the required curve. This is z. So next example, second one, To find the area under standard normal curve for z equal to minus 0.86 and z equal to 0. So for this, the curve will be same. The area, the formula for area is 1 by square root of 2 pi integral over here. Now the limits between minus 0.86 to 0, e raised to minus z square by 2 dz. This is nothing but, by the symmetry, we can write it as 1 by square root of 2 pi. So just interchange the limit, that is by symmetry to dz. If you want, mention here by symmetry. So then this is nothing but phi of 0.86. So just use the table now. Just by the table, the required area is phi of 0.86. Again, just go to the table, find phi of 0.86. Phi of 0.86 means 0.8 is here, move along the vertical line, 0.8, now move horizontally up to 6. So for 6 it is 0.3051. So phi of 0.86 is 0.3051. Now for this, how will be your required curve now? Required curve will be this is z axis, then the if curve moves along this is your phi of z, then this is z, this is z, here z equal to 0, then it is a minus 0.86, so minus 0.86 somewhere here, then it is left side of your z equal to 0, it covers the required area. This is the graph of geometrical figure of the curve. Now third example, z is minus 0.44, z equal to minus 0.44 and 1.76. So area, it can be written as 1 by square root of 2 pi integral over minus 0.44 to 1.76 e raised to minus z square by 2 dz. Again, I may write it as 1 by square root of 2 pi minus 0.44 to 0 e raised to minus z square by 2 dz plus 1 by square root of 2 pi integral over 0 to 1.76 e raised to minus z square by 2 dz. So I splitted the intervals. So this is equal to 1 by square root of 2 pi by symmetry. It is from 0 to 0.44 e raised to minus z square by 2 dz plus 1 by square root of 2 pi 0 to 1.76 e raised to minus z square by 2 dz. So we can write this as phi of 0.44 plus phi of 1.76. So this is equal to, now just refer the table, 0.44 0.4 vertically 0.4, then move horizontally up to 4, so it is 0.1700, and 1.76 move downwards 1.7, so up to 6 horizontally, so it will be 0.4608, so 0.1700 plus 0.4608, when you add these two you get 0.6308. For this curve will be equivalently, we can write this as probability of z lying between minus 0.44 and 1.76 is equal to 0.6308. So for this curve look like area of the between these 2 points of the given curve is, this is a phi offset, so 1.76 will be somewhere here, and minus 0.44, so it is just somewhere here, so it is 0, it is 1.76, it is minus 0.44. So this part, this portion, the shaded portion is the required area now. So next one, fourth example, area for the standard normal curve between z equal to 0.57 and z equal to 2.49. So now here both the values are positive. In the previous example one is negative and another one is positive. Now here both the values positive means what? The area is, it will be right side of your z here. So required area between z is given by z equal to, so now we can split it 0.57 and 2.49. So from between 0 to 2.49 plus just we are finding the area. So from 0 to 2.49 and then 0.57. So we subtract minus so our required area, so just a minute, required area is given by area between z equal to 0 to 2.49 minus area between z equal to 0 to 0.57. So we want area between 0.57 to 2.49. So find separately area between 0 to 2.49 and area between 0 to 0.57 and subtract them. So this is nothing but first one, since it is from 0 to 2.49, directly we can write phi of 2.49 minus phi of 0.57. Then by referring the table 2.49, again use the table and move vertically down 2.4, then along horizontally just 9th column, so it is 0.4936. 2.49 is 0.4936 and 0.57, just 0.57 is 0.5 is here, then move horizontally up to 7th column 0.57, this is 0.2157. So write the respective value and subtract. So it will be 0.4936 minus 0.2157. When you subtract, you will get 0.2779. Equivalently, we can write this as probability of Z between 0.57 and 2.49 is 0.2779. For this, curve will be this is your phi of Z. This is Z equal to 0. So 0.57 will be some more here. 0.57 and 2.49. 2.49. So area will be between these two. So this part is shaded part is the required area of the curve between these two points. So next example, area of the standard normal curve to the right of Z equal to minus 1.85. So area between minus 1, area after the right of minus 1.85 they are asking. So required area is equal to area between Z equal to minus 1.85 to 0 and plus area between area to the right of Z equal to minus 1.85. So now this is nothing but phi of 1.85. So we need to change this to 0 to minus 1.85. That is, first one is area between Z equal to 0 to 1.85 plus remaining as it is. So phi of 1.85 and area from the right, it will be always 0.5 as we mentioned before. So now just use the table and find the value for 1.85. For 1.85 in the table, find 1.85 more vertically than the fifth column. So it will be 0.4678. So 0.4678 plus 0.5. Then when you add up, so it becomes 0.9678. So what will be the graph? This is nothing but equivalently same thing we can write it as probability of Z greater than minus 1.85. This is nothing but 0.9678. So graph will be this is your phi of Z, this is Z, then 0, minus 1.85 somewhere here. They asked you to find the area from right of the minus 1.85. So this whole portion is required. Next example, evaluate the following probabilities with the help of normal probability tables. Just as we did in the previous example, just use the standard table and write the values. First one, probability of Z greater than or equal to 0.75. So we can write this as probability of Z greater than or equal to 0.75. It can be written as probability Z greater than or equal to 0 minus probability Z lying between 0 to 0.75. So when you subtract these two, we'll get the probability of this. So this is standard, it will be 0.5. So it is nothing but phi of 0.75. Just use the standard probability table. 0.75 will be 0.2734. So when you subtract these two, it will be 0.2246. So probability of Z greater than or equal to 0.75 will be 0.2246. Next, second one, probability of minus 1.64 less than or equal to Z less than or equal to minus 0.88. By symmetry, this can be written as probability of Z lying between 0.88 Z less than or equal to 1.64. So by using the symmetry, we can remove this negative signs that using that property. Therefore, probability of minus 1.64 less than or equal to Z less than or equal to minus 0.88 is probability 0 Z lying between 1.64 minus Z lying between 0 to 0.88. So this is nothing but phi of 1.64 minus phi of 0.88. Just use the table, write the values according to table. Phi of 1.64 is 0.4495 and this is 0.3106. So it will be 0.1389. So this is probability of Z lying between minus 0.164 and minus 0.88 is 0.1389. Probability of Z less than or equal to minus 2.43. So this is nothing but by using the symmetry, we can write this as probability Z greater than or equal to plus 2.43. So this is nothing but probability Z greater than or equal to 0 minus probability Z lying between 0 and 2.43. Again this is fixed, that is 0.5, and this will be written as phi of 2.43. So 0.5 using the standard table, phi of 2.43 is 0.4925. When you subtract, you will get 0.0075. This is probability of Z less than or equal to minus 2.43. Fourth one, to find the probability of mod Z less than or equal to 1.94. Mod Z means what? You can write this as probability of minus 1.94 less than or equal to Z less than or equal to plus 1.94. So this is how to write modulus of Z. So this is nothing but we can write it as 2 times probability of Z lying between 0 to 1.94. Anyhow, we using symmetry we turn out this minus 1.94 to plus 1.94. That's why we wrote 2 times probability of this. So this is nothing but 2 times probability of phi of 1.94, phi of 1. So now 2 times 0.4738. So this is 0.9476. So probability of modulus of Z less than or equal to 1.94 is 0.9476. Third one, if X is normal variate with mean 18 and standard deviation 3, find the probability that x lying between 14 and 28 and x greater than or equal to 23. So in this example you are given with the mean and standard deviation. So for the normal probability distribution we have z equal to x minus mu by sigma. Here mu is that is mean 18, sigma standard deviation is 3. So x minus 18 by 3. So first one, probability of x lying between 14 and 28. So if x is 14, z equal to, so when you substitute here 14 minus 18 divided by 3, so you will get, when you simplify you will get 1.3. and if x is 28, z will be 28 minus 18, 10 by 3, so it will be 3.3. Hence we need to find probability between minus 1.3 for z we are finding, no? That's why we found the z limits for z now, minus 1.3 to 3.3. That is probability of minus 1.3 less than or equal to z 3.3. It can be written as probability of minus 1.3 z less than or equal to 0 plus probability of 0 less than or z less than or equal to 3.3. Again, by using this symmetry we can write this as 0 less than or equal to z less than or equal to 1.3 plus this one is same, 0 less than or equal to z less than or equal to 3.3. So this is nothing but phi of 1.3 plus phi of 3.3. Just use the standard table and write the respective value, that is 0.04032 plus this will be 0.4995. Add them, you will get 0.9027. This is what probability of x lying, that is z lying between minus 1.3 to 3.3, that is nothing but probability of x lying between 14 to 28. So next, second one, to find probability of x greater than or equal to 23. If x is 23, z will be 23 minus 18 by 3, so that would be 5 by 3, that is 1.66. So hence we have to find probability of z greater than or equal to 1.66. That is probability of z greater than or equal to 1.66 can be written as probability of z greater than or equal to 0 minus probability of z less than or equal to 1.66. This is standard 0.5 minus phi of 1.66. Use the table and the value is minus 0.5 minus point. So 0.5 minus 0.4515 will be 0.0485. So that is probability of x greater than or equal to 23 will be 0.0485.